What if a single open-source model could match GPT 5.3 codecs and Claude Opus 4.6 on real-world coding tasks, and run it on hardware you already own? That's exactly what DeepSeek V4 is promising. And if their numbers hold up under independent testing, it's going to shake up the AI world again. I'm going to break down everything we know about DeepSeek V4, the new architecture, the benchmark claims, how it compares to Claude 4.5, and yes, how you can actually self-host it yourself. So what exactly is the new DeepSeek V4? DeepSeek V4 is a 1 trillion parameter coding-focused AI model launching in mid-February 2026. It's built by the Chinese lab DeepSeek, the same team that shocked the world with R1, which matched GPT-4 at a fraction of the training cost. This is a mixture of experts model, which means even though it has 1 trillion parameters total, it only activates about 32 billion for any given task. That's how it stays fast and affordable, while still having the raw capacity of a Titan-class system. And crucially, it's open weight, Apache 2.0 licensed. That means you can download it, self-host it, fine-tune it, and deploy it on premises. No API required. Now here's where it gets really interesting. DeepSeek V4 isn't just a bigger model. It ships 3 brand new architectural breakthroughs. The first is DeepSeek Sparse Attention, or DSA. Standard transformers have a huge problem. Their compute costs scale quadratically with context length. Double the context, and you quadruple the cost. DSA solves this. It uses an intelligent system to focus compute only on the most relevant parts of the context, bringing that scaling down to roughly linear. The result? Context windows exceeding 1 million tokens at 50% lower cost than standard attention. For coding, that means V4 can read your entire repository in a single pass. Every file, every dependency, every import, all at once. The second innovation is one of the most talked about, DeepSeek V4 Engram. Think about how current AI works. Every time you start a conversation, it knows nothing. It has no memory. Engram changes that. It's a conditional memory module that stores key information, your preferences, past decisions, project standards, in a vector database. When you start a new session, it retrieves only what's relevant. No noise, no wasted tokens. For a code generation agent, that means it can remember your team's naming conventions, architectural patterns, and past bugs, and never repeat the same mistake twice. That's genuinely new. The third innovation is MHC, Manifold Constrained Hyperconnections. This one's more under the hood. It rethinks how information flows during training, solving a numerical instability problem that has limited how wide and deep these residual networks can go. The result is 30% faster training convergence, which means DeepSeek built this frontier model for an estimated $10 million, compared to the hundreds of millions OpenAI reportedly spent on GPT-4. So how does DeepSeek V4 actually stack up? Let's talk numbers. The benchmark everyone watches for coding AI is SWE Bench Verified. It tests whether a model can solve real-world GitHub issues across actual code repositories. Right now, Claude Opus 4.6 leads the field with an 80.9% solve rate. DeepSeek V4's internal testing claims to exceed 80%, which would put it in the same tier. In the DeepSeek V4 versus Claude 4.5 matchup, the real differentiator isn't performance, it's price. DeepSeek V4 API pricing is reportedly 27 cents per million input tokens. Claude Opus 4.6 is $15 per million tokens. That's a 55 times difference. and compared to Grok 5 and GPT 5.3 codecs? DeepSeek still runs closed-source competitors close on benchmarks while undercutting them dramatically on cost. Now, these are internal benchmark claims. Independent verification hasn't happened yet, but if they hold, this is a genuine disruption. Here's the part you probably came for: how to actually use DeepSeek V4. There are three main ways. First, you can use it via the DeepSeek API or web interface once it's live, just like ChatGPT or Claude. Second, if you want to add DeepSeek V4 to VS Code, you'll use an extension like Continue or Cline, point it at the DeepSeek API endpoint, and you're coding with it inside your editor in minutes. I'll link a full tutorial in the description. Third, and this is where DeepSeek gets unique, you can self-host it. The weights are open under Apache 2.0. For the distilled 32B version, you can run it on a single RTX 4090. For the 70B distilled, dual RTX 4019s. For the full 1 trillion parameter model, you're looking at enterprise GPU configurations, but the efficiency gains still make it far more accessible than any comparable Western model. For self-hosting, you'll use tools like Ollama, LM Studio, or vLLM. Pull the model, configure your API endpoint, and your data never leaves your machine. So here's the bottom line on the new DeepSeek V4. A trillion parameter open source model with 1 million token context, persistent Engram memory, 50 times cheaper API pricing than Western competitors, and the ability to run locally on consumer hardware. The benchmark claims are still unverified, but so was R1 before launch, and we all know how that turned out. If you want to stay ahead of this, subscribe, hit the bell, and drop a comment. Are you planning to self-host V4, use the API, or add it to VS Code? Let me know below. Links to everything we talked about, including how to set up DeepSeek V4 as a local open code environment, are in the description.